Good good morning to all of you. Myself, Professor N.V. Adpe from SNT College of Engineering and Research Center, Yerla. Today, we are discussing the new topic, that is the topic of course, electrical measurement and instrumentation. In that, we have studied the measurement of power. Measurement of power. This is the third unit of electrical measurement and instrumentation subject course. In that first topic is working principle of dynamometer type wattmeter. This is the circuit diagram or and the connection diagram of dynamometer type wattmeter. Dynamometer type wattmeter works on the very simple principle, that is, whenever current carrying conductor placed inside a magnetic field, then it expresses a mechanical force, and due to this mechanical force, the deflection of conductor takes place. Means when the current carrying conductor, that is current coil, is placed in a magnetic field, this is produced by the potential coil or the voltage coil, then the force will be exerted or the experience in a scale. Uh, the force will be experienced on the pointer. This is the construction. Now construction of uh, dynamometer type wattmeter. First is moving coil, second is fixed coil, control system, damping system, and scale. The first moving coil moves the pointer with the help of spring control instrument. Move the pointer by using the spring control instrument. A limited amount of current flows through the moving coil so as to avoid heating. So in order to limit the current, we have connected the high value of resistance in series with the moving coil. This high value of resistance which is connected in series with the pressure coil. The moving is air cooled and is mounted on a pivoted spindle and can move freely. In electrodynamometer type wattmeter, moving coil works as a pressure coil. Moving coil works as a pressure coil. Hence, moving coil is connected across the voltage, and thus the current flowing to the coil is always proportional to the voltage, supply voltage. The fixed coil is nothing but your current coil. The fixed coil is divided into two equal parts, and these are connected in series with the load. This fixed coil, this is current coil. This will be divided into two same parts, and this will be connected in series with the load. Connected in series with the load. Therefore, the load current will flow through this coil. Now the reason is very obvious of using two fixed coils instead of one. So it can be constructed to carry considerable amount of electric current. For for the for the for the adjustment of the electric current, we have convert this coil into two parts. These coil are called as current coil, or this is a current coil of electrodynamometer type wattmeter. Earlier, these fixed coils are designed to carry the current of about 100 ampere, but now the modern wattmeter are designed to carry about up to only 20 amperes in order to save the power. In order to save the power, the control system out of two controlling settings, that is gravity control and spring control, only spring control system are used in this type of wattmeter. The spring controlled system will be used, which is used in the watt in this type of wattmeter. Gravity control system cannot be employed because they will contain appreciable amount of errors. In gravity control system, there is some error will be which is present. Due to that, we use only the spring controlled system. Next, damping system. Air friction damping is used as eddy current damping will distort the weak operating magnetic field. As eddy current damping will distort the weak operating magnetic system and thus it may lead to error. Therefore, we use the air friction damping scale. There is a uniform scale is used in this type of instrument as moving coil moves linearly over a range of 40 degrees to 50 degrees on either side. Means the scale will be designed and this will be shown on the scale. This will be read by the pointer. This is your construction diagram of dynamometer type wattmeter. This is fixed coil, current coil which is connected in series with the load, and moving coil or the pressure coil which is connected across the load or the supply voltage, and it having connected series resistance, high value of series resistance in series with the pressure coil to avoid the heating. This is a pointer. This will be connected to the moving coil. When this coil will be moved, then according to that, this pointer will be moves. This pointer will be moved and shows the wattage reading. Shows the wattage reading. Now, what types of error which is available in the electrodynamometer type wattmeter, that is errors in the pressure coil inductance. Second, errors may be due to pressure coil capacitance. Errors may be due to mutual inductance effect. It may be due to the connections, that is pressure coil is connected after the current coil. Suppose pressure coil is connected after the current coil, then it will be also produces the error. This is called as connection error. Error due to the eddy current. Error caused by vibration of moving system. Temperature error and error due to stray magnetic field. These are the errors which is produced in the or which is available in the electrodynamometer type wattmeter. Now we will explain one by one. First, error due to pressure potential coil inductor. The inductance of potential coil is liable to cause an error in the reading of the wattmeter because the wattmeter gives a high reading on lagging power factor and low reading on leading power factor due to the pressure coil inductor. Means at the lagging power factor it shows the high value reading and at leading power factor it shows the low reading. The high non-inductive resistance is connected in series with the coil swamp the phasing effect of the potential coil inductor. Next, second, error due to the power loss in the potential coil or current coil. Another possible error in the indicated power may be due to some voltage drop in current coil or the current taken by the pressure coil. Means due to the voltage drop of current coil and pressure coil, due to this the power losses should be produced and this will the wattmeter shows the faulty reading or the error reading. This winding is we have overcome this effect by using an additional compensating winding. This is connected in series with the potential coil. So place that it produces a field in the opposite direction to that of the current coil. Means the opposite direction magnetic field will be produced up to the current coil to reduce the current coil magnetic field. Next is error due to the eddy current. The alternating field of fixed or fixed current coil induces eddy currents in the solid metal parts which set up their own magnetic field. Due to the current flowing to the current coil, it produces the magnetic field. This alters the magnitude and phase of the magnetic field, causing the deflection and thus an error introduced in the instrument reading. This is called as error due to the eddy current. Eddy current. To reduce this error, the solid metal parts placed far away from the current coil as possible. Means in that the current coil will be insulated from the other metal instrument. Error due to stray magnetic field. The dynamometer type wattmeter has a relatively weak operating field. Therefore, stray fields affect the reading of this instrument considerably and causes serious errors. In that, it must be shielded against stray magnetic field. Try using iron cases or providing iron sheets over the working part for reducing the stray magnetic field. The advantages of this dynamometer type wattmeter is it can be used for measuring the both AC and DC power. It has a uniform scale. Next, you can obtain a high degree of accuracy through careful design. But at the disadvantages is at low power factor, the inductance of the potential coil causes serious errors. Means as the power factor decreases, then it will be the inductance of potential coil, that is pressure coil inductance, this will be produces an error. The reading of the instrument may be affected by stray magnetic field and this will be prevented or this error will be minimized by using shielding or enclosing the instrument in an iron case. This is a construction working principle errors which is produce advantages and disadvantages of the dynamometer type wattmeter. Okay, thank you.